All right, let's dive into something that, and I mean this literally, holds our entire world together. It's incredibly powerful, it's super precise, and it's happening all around you every single day. We're talking about arc welding. So let's get a closer look at how this whole thing works.
So I want to start with a really big question. I mean, when you look around at these incredible feats of engineering, how do we actually build them? How do we take these giant pieces of metal and turn them into something solid, something permanent?
Well, the answer, more often than you'd think, is found in the weld. You see, every skyscraper that towers over a city, every massive ship crossing the ocean, even the car you drive, they all rely on the unbelievable strength of joining metal to metal. And the tech that makes it all possible is, well, it's both shockingly simple and incredibly powerful.
Because really, at its heart, this whole process is about harnessing the power of electricity. It's about creating what is basically a controlled bolt of lightning to literally melt and fuse steel together. It's this brilliant, intense flash of energy that's the real foundation of modern construction.
So what exactly is arc welding? Well, the best way to think about it is like creating a tiny, intensely hot sun right where you need it to fuse two pieces of metal into one.
Okay, so here's the technical breakdown. You've got an electric current flowing from a metal rod, we call that the electrode, to the metal you're actually working on, which is called the workpiece. That current has to jump a tiny gap, and when it does, bam, it creates an electric arc. And this arc is insanely hot. So hot it melts both the electrode and the workpiece, creating this little molten pool that then cools down to form a single super strong piece of metal.
But, it's not quite that simple. There's a huge problem, a kind of hidden enemy that can totally weaken a weld and make it fail. And that enemy? It's the very air we breathe. The oxygen and nitrogen in the atmosphere, they can get into that molten metal and make the final joint brittle and weak.
And that right there brings us to the real secret behind all modern arc welding, the idea of shielding. To get a strong weld, you absolutely have to protect that little pool of molten metal from the air. And how you do that shielding? Well, that's what defines all the different types of welding we're about to talk about. So it really boils down to two main strategies for protecting the weld. First, you've got flux shielding. This is where a solid material, the flux, is coated right onto the welding rod. When that burns, it releases a protective gas and also forms this hard layer called slag over the weld for extra protection. Then, on the other hand, you have gas shielding. This is where you use a tank of inert gas, something like argon, and you pump a steady stream of it over the weld. It basically creates an invisible force field that keeps the air away.
Okay, so now that we get the core idea of shielding, let's look at the real workhorses of the industry. These are the types of welding you are most likely to see out in the world.
First up is the granddaddy of them all. This is one of the most classic and versatile types, Shielded Metal Arc Welding, or SMAW. But you probably know it by a much more common name. That's right, stick welding. This is the image you probably have in your head of a welder. It uses a consumable electrode, the stick, that is coated in that solid flux we just talked about. As the stick burns, that flux creates the protective gas shield. The reason this is so popular is that it's a totally self-contained system. You don't need a heavy gas tank, which makes it super portable and absolutely perfect for repairs out in the field.
Now, what if you wanted to make this whole process faster, more automated? Well, that brings us to our next one, Gas Metal Arc Welding, or GMAW. This was a real game changer for speed and efficiency.
Most people know this as MIG welding. Now, unlike stick welding, where you have to keep stopping to put in a new electrode, MIG uses a thin wire that's fed continuously from a big spool right through the welding gun. And as you can probably guess from the name, it uses that second shielding method. An external tank of gas flows through the gun to protect the weld. This continuous process makes it incredibly fast, which is why it's the absolute engine of modern manufacturing.
And just to give you an idea of how dominant this is in manufacturing, check this out. According to the American Welding Society, MIG welding accounts for a staggering 60% of all welding in the United States. 60%! So when you think of assembly lines in industrial factories, you're pretty much thinking of MIG welding. So we have the portability of stick welding, and we have the speed of MIG. What if you could get the best of both worlds? Well, that's exactly what our next type tries to do. Flux Cord Arc Welding, or FCAW. This one is a really clever hybrid. So like MIG, it uses a continuously fed wire. But here's the cool part. The wire isn't solid. It's actually a hollow tube, and the inside is filled with flux. So as the wire melts, that flux core releases its own shielding gas, just like a stick electrode does. This gives you the speed of a wire-fed system, but without needing a big, clumsy gas bottle. That makes it fantastic for heavy-duty outdoor construction.
All right, now let's scale things way up. We're moving away from general everyday stuff and into the world of truly massive projects. We're talking shipyards, pressure vessels, the really big stuff.
First up is submerged arc welding, which is wild because you can't even see the arc. The machine lays down a thick layer of this grainy, sand-like flux over the joint, and the welding wire travels completely underneath it, totally submerged. This creates a perfectly protected environment which gives you these incredibly high-quality, deep welds that you need for joining really, really thick plates of steel.
So, okay, how do you weld a massive steel plate, but vertically? That's the unique problem that electrogas welding, or EGW, was designed to solve. It's a highly automated process, really just a variation of MIG welding, that moves upward between two giant plates, continuously filling the gap. It's super specialized, but absolutely crucial for things like building the hulls of giant ships.
Okay, so we've gone from massive scale, and now we're going to pivot to incredible precision and some very specific jobs. Think of these as the specialty tools in the welding world.
Plasma arc welding, or PAW, just takes heat to a whole other level. It uses electricity to create this super focused jet of ionized gas, which is what plasma is. This plasma stream is way hotter and much more focused than a standard welding arc, which lets you make these incredibly fine, high-quality welds on really thin materials. And that level of precision is exactly why it's a favorite in places like the aerospace and automotive industries.
And finally, something completely different: stud welding. This isn't about joining two plates together, it's about attaching a fastener, like a bolt, to a surface in the blink of an eye. A special gun holds the stud, creates a super brief arc that melts both surfaces, and then plunges the stud right into the molten pool. The whole thing takes less than a second, and it creates a perfect permanent bond. It's amazing to watch.
Whew! So we've covered a lot of ground here, right? From simple sticks to automated plasma jets. Let's just boil it all down to the one core concept that connects every single one of them.
Because really, when you get right down to it, no matter how complex the machine is, every single process we talked about follows this one fundamental formula. You need an electric arc to create the intense heat, and you absolutely need a protective shield, whether it's from gas or from flux, to make sure the weld is strong and free of defects. That, right there, is the secret to all modern welding.
So, the next time you cross a bridge, or you look up at a skyscraper, or even just check out the sleek lines on a car, you'll know. You'll know about the invisible power that's holding it all together. You know the secret of the arc and the shield. So the question is, where are you going to see it next?